As the blades of our wearing blender spin through liquefied food, forces other than cutting are responsible for most of the work of blending. A powerful shearing force drives circulation by sucking liquid down from the top of the pitcher and then violently flinging it out to the sides. Here, as oil tries to slip past the fast-moving blades, the turbulence literally rips it into minuscule droplets that are dispersed into the surrounding liquid to create a rich, smooth emulsion. A remarkable amount of engineering effort goes into the design of the blades and pitcher to maximize this force. Those of you watching this video closely might notice another oddity. As the blades begin to spin, an uncountable number of bubbles stream from the tips and trailing edges of the blades. This is the telltale sign of cavitation. These bubbles are tiny holes ripped into the surrounding fluid. Cavitation might seem benign, but when these bubbles collapse, a powerful shockwave reverberates through the liquid that breaks apart surrounding bits of food. Indeed, cavitation is powerful enough to shatter glass. Quickly smacking the top of this glass bottle, for example, creates a brief moment where a few cavitation bubbles appear within the water. When these bubbles pop, the resulting shockwave propagates through the water to the surrounding glass bottle, shattering it instantly. Although it's too fleeting for the eye to see, this same phenomenon is occurring every time you flip the switch on your wearing blender. The impact of these shockwaves is immense and breaks surrounding particles of food into incredibly small pieces. This is the unseen force that a blender uses to cut foods down to size.